So formal definition of Turing machine, M is equal to Q summation tau delta Q0 B and F. Q stands for set of states, which is finite. Summation is the input alphabet. This tau, this is the tape alphabet. Then we have the transition function. This is the start state Q0. B stands for blank symbol. So this is important. Blank symbol. F is a finite set of final states. So this is your final state. So here in Turing machine, as we discussed, we are having an input output tape, a read write head, finite state control. The head can move in both the directions, left to right to left. And that's why we are having this tape alphabet also. So as we can perform read and write operations on the input output tape, this tape alphabet is very important. Now this blank symbol that is given, that is usually present around your input. So whatever input is there, that is written between this blank. So whenever we are taking example in Turing machine, there is a blank symbol present to the left of the example and to the right of the example. Now this Turing machine, so all the problems that were solved by push-down automata can also be solved by Turing machine. Turing machine has more advantage as compared to push-down automata. More functionality and more advantage. So we'll start with the first problem that we had taken for push-down automata. L is equal to A raised to N, B raised to N, where N is greater than or equal to 1. L is equal to A raised to N, B raised to N, where N is greater than or equal to 1. Now here there is no memory involved, as it was there in push-down automata. Now here, what do we need to do? We can use the movement of the read-write head from left to right and right to left, and also perform write operations on the tape and solve this particular problem. So first few problems I'll be explaining it to you, then you can find the logic for the problem. So the logic for this particular problem will be, we have a state Q0 in which when we are present, if we get an A, we make it as X. In Q1, so Q0, if we get A, we make it as X. In Q0, we make A as X. In Q1, we make B as Y. So different symbols are used on the tape. Blank symbol is already present. Then Q2 is a state which is used to come back. For coming back, we'll have this particular state. And then we have Q3, which is used for checking. So we'll come to know one by one. And QF is the final state. So I'll tell you the logic for the problem, and then we'll start with the transition function. So this is the logic that we'll be using. Now we'll take an example and see how it works. So A raised to N, B raised to N. Example for this will be, we can have 3 A's followed by 3 B's. So this should be accepted. A raised to N, B raised to N. So initially we'll be in Q0. We are here, we'll be in Q0. What is the function of Q0? To make A as X. So we'll make this A as X and move to the right. Okay. But after we make A as X, we change the state to Q1. What is the function of, what is the logic for Q1 that we have defined? Q1 will make B as Y. So Q1 will keep A as it is and keep moving to the right. When it gets the first B, it will make it as Y. Now it changes the state. It goes to the next state, that is Q2. So Q2, it is used for coming back. So it will start moving to the left. So Q2 helps you to move to the left. So it will keep on moving till when it will keep on moving? Yes, it will keep on moving till the time it finds X. And once it finds X, it does not perform any operation. It will just change the state and start moving to the right. So once it finds X, yes, it changed the state to Q0 and starts moving to the right. Then when we get A, we make it as X, change the state to Q1, keep moving to the right. Then we get A, Y, Q1 will not perform any operation. When we get B, we'll make B as Y. And then we change the state to Q2. So Q2 is used for coming back. So it will start moving to the left. So it will start moving to the left till the time it finds this X. Then it will change the state to Q0. Again, Q0 will make this A as X. Then it will move it will change the state to Q1. Q1, it will keep on moving to the right and then it will make B as Y. Now it goes to Q2. Q2 is used for coming back. It will come back till the time it finds this X. And after X in Q0, when you get Y, we go to the state Q3. Q3 is used for checking. Yes. Q3 is used for checking. So immediately when you get Y, we go to Q3. So Q3, it will scan. Now all the B's should be converted to Y. If you find B, it will get stuck in between. So Q3 will keep Y as it is and keep moving to the right. So it will keep moving to the right till the time it finds this blank symbol. So as soon as it finds the blank symbol, it will go to the final state. So as soon as it finds the blank symbol, it will go to the final state QF. Are you getting? Yes. So here, what we are doing is we are using this particular read write head and moving from left to right and right to left, left to right and right to left. We are performing operations on the input output tape. So A, we make it as X, then we move to the right. We move to the right till we find a B. So B, we make it, as soon as we find B, there is a state which makes B as Y. Then we start coming back. We come back till the time we find X, and from X, you change the state, then you go to the right, find A, make it as X. Then you keep moving to the right, change the state, and then when you find B, make it as Y. When all the A's have been converted to X and B's have been converted to Y, what do? We just check whether all the conversion has happened or not. And once it is done, what do we do after that? We go to the final state when we find the blank symbol. So this blank symbol is very important when we are solving problems. Are you getting it? Now the transition function here that is present, here it is little different. So we'll be drawing the transition function. After that, it will be more clear. Transition function and the diagram, and then we'll solve the example again. So state versus the input tape symbol. So this tau is the input tape symbol that we have seen here. So Q versus the input tape symbol is the transition function. So it gives us, after that it will give us the state, the input tape that will be present. So this gives us a state, then the input tape symbol that will be present, and then the movement. It will be left, right, or staying at the same place. So these three components will be present in the transition function. So you'll have q versus tau. So state versus the tape symbol, that will give us state versus the tape symbol plus the tape symbol plus the movement to the left right. So this will get clear when we draw the transition function. Just pay attention when I'm solving so that it becomes clear for you. So this is your state versus the tape symbol. So whatever states we have chosen there. So we had chosen Q0. This was making A as X. We are starting with Q0. Then Q1, its function was making B as Y. Q2 is for comeback. Q3 is for checking. And QF is the final state. Okay. And the tape symbols, we are having either A or B, or we can have X, or we can have capital Y, or we can have blank symbol B. So state versus the tape symbol will give us state, tape symbol, and left right movement. So we'll understand it along with an example that we had taken there. Triple A, triple B. We are in Q0 here. Q0, what is the function or what is the logic that we have used? Wherever it finds A, make it as X. So Q0, when it gets A, we change the state. We go to the next state, that is Q1. Keep A. We don't keep A as it is. We change A to X. And then we keep moving to the right. Are you getting this? Q0, when we get A as the input, we change the state to Q1, make A as X and start moving to the right. So we make A as X and start moving to the right. Now we are in Q1. So Q1, if we get A, so Q1, it is not supposed to do anything with A. It is supposed to change B to Y. So Q1, it will stay in the same state, keep A as it is and keep moving to the right. So Q1, when it gets A, it stays in the same state. As soon as it finds A, it keeps it as it is and starts moving to the right. And as soon as it finds B, it changes the state, which is the next state. It is Q2. B will be changed to Y and it starts moving to the left now. So B will be made as Y and it will start moving to the left. And we change the state to Q2. Now Q2 is present here. Now it has moved to the left. So it will encounter A's. So Q2, when it gets A, it will not perform any operation. It will keep on moving to the left. So Q2, there is no change of state. A is kept as it is. It keeps moving to the left. As soon as it finds X, so you will come here. So Q2, as soon as it finds X, it changed the state to Q0 now. X is kept as it is. And now it starts moving to the right. So once it finds X, It keeps X as it is, starts moving to the right, which is, and you are in Q0. So Q0, when you get A again, you will make A as X. So you have made A as X and changed the state to Q1. So first row and first column, the transition that we have written will get executed. So you will move to Q1, X will be made as A will be made as X, and you keep moving to the right. Now in Q1 you get A, there is already a transition, you keep A as it is, keep moving to the right. Now Q1, when you get Y, there is no transition, so we write the transition for that. We stay in Q2, we stay in Q1. Change of state occurs when its function is done. What is the function of Q1? To make B as Y. Then you change the state. What is the function of Q0? To make A as X, and then you change the state. What is the function of Q2? To come back. Till the time you get X. Now Q1, when it gets Y is kept as it is. You keep moving to the right. Now it will get B. You will make B as Y and change the state to Q2 and keep moving to the left. Now in Q2, when you encounter Y, you're not supposed to do anything. So Q2 keeps Y as it is and keeps moving to the left. Then you encounter A, you keep as it is. Then you encounter X and start moving to the right. Now when you start moving to the right, you change the state to Q0. Now we are in Q0, you make A as X. Then you change the state to Q1. Q1, it finds Y. It finds Y and keeps moving to the right. Keeps moving to the right. When it gets B, makes this third B as Y and changes the state to Q2. Q2 will keep moving to the left. Y will be kept as it is. X will be kept as it is. And once you find X, you start moving to the right. Now we are in Q0. Q0, immediately when you get Y, after your X, there is no A present. So all the A's have been converted to X. Now you will go to the state Q3 and Y will be kept as it is. You keep moving to the right. Now you may encounter more Y's. So we stay in the same state as Q3. Keep moving to the right. Now when you encounter blank here, that time we change the state to QF and keep blank as it is and stop there or stay at the place. Are you getting this? And QF is your final state. There is no need to write any transition. Just mention this as the final state. Yes? Have you understood this, Madhur?
Yes, sir.
Yashika, have you understood?
Yes, sir.
Now we need to understand how to make a transition diagram for this problem. So this table we will keep in front of us to make the transition diagram. Q0. First transition is Q0 to Q1. So Q0 to Q1. When it happens, when we get A, so A is changed to X and we keep moving to the right. Here there is a difference. Earlier it was for PDI what we used to have, the input stack top element, and then what is getting converted, that was written, or push or pop element, push or pop operation is happening, that we used to write. Here what do we do? The input, what it is converted to. So A is made as X and then you keep moving to the right. Now Q1, we are having transitions Q1 to Q1. There is a transition. A is there, which is kept as A, and we keep moving to the right. Then Q1 to Q1, Y is present, Y is kept as Y, and we keep moving to the right. Q1 is changed to Q2. When it happens, when we get B, P is changed to Y, and we start moving to the left. So this is how you need to draw the transition diagram. Then Q2, A is kept as A, we keep moving to the left. Y is kept as Y, we keep moving to the left. And then when we get X, we go to Q0. So X is not changed, X is kept as X, and we keep moving to the right. In Q0, when we get Y, that time we move to Q3. Y is kept as Y, we keep moving to the right. Now in Q3, if there are Y's present, Y will be kept as Y, we keep moving to the right, and we go to the final state QF when we find a blank symbol. Blank symbol, it is kept as blank, and we stay at the same place. Are you getting this? Yes? See, when you solve more problems for this Turing machine, it will be clear for you. You may find it a little complicated as compared to the previous DFA, NFA, push down automata. But once you understand it, you will enjoy solving problems for Turing machine. Now we'll take one example and solve it. Now till the previous example that we had seen, we were just overwriting it. We need to write it step by step whenever we are solving example. So in step 5, we have example. So in this way, if you write, it will be better. So first in Q0, when we get A, we change the state and make A as X. So A will be made as X. The remaining part of the string remains as it is. And the state is changed to Q1. So Q1 on A, it will not perform any operation. Then you have to show that it is moving ahead. So next step, you can show this Q1. I'm not writing. You have to show it step by step. So it will be better. When it comes to this B, it changes the state to Q2 and starts moving to the left. And your B is changed to Y. So B, sorry, first blank X, then you have A, then you have this B, which is changed to Y. And we are here in the state Q2. Now the Q2 is for coming back. It will come back till here. And when it goes to the right, when it finds X, it changes the state. And then we have to show that also, that we are in Q0 here. Now after this, your a will be converted to x. Like that, we need to keep on solving and change the states and show it step by step. Are you getting it? Now you may be thinking that you have understood it. You need to practice it now. So for practicing this, what we'll be doing is we'll take one more sum, which is similar to what you have done till now, just that you will do it on your own. Few changes will be there. This much everyone has understood. Yes.
Yes.
Abhishek.
Yes. Yes, sir.
So we'll take one more problem, which is similar to what you have done now, but you'll be doing this one on your own. 0 raised to n, 1 raised to n, where n is greater than or equal to 1. What is the change here? Instead of a and b, we are having 0 and 1. Yes. So try to do it on your own. The logic part, the implementation part, you try to do it on your own and then see where you're getting stuck or what you have not understood, which part you are missing. Yes.